This is a video for AQA Further Pure Mathematics, Algebra and Graphs, section 4.2, which looks at the idea of inequalities involving the modulus function. Well, the process for solving inequalities with moduli is really the same as with any other functions. So one way is to sketch graphs of the functions on the same axes and look at the critical points where those graphs intersect. The slight difference will be that the algebra, we have to consider whether we're looking at a portion of the graph which has come from a reflection of the original function when we have the modulus. So remember that if we're looking at mod f of x, then if that f of x is less than 0, then the modulus will be a reflection, and that has to be considered then in the algebra. But once we've found those critical points, then we can use the graph to help solve the inequality. So let's look at that with a specific example. Here we've got the modulus of x squared minus 3, and we want to know when it's greater than 2x. So the graph here shows x squared minus 3, and the portion which is below the axis has been reflected so that the green solid line is our graph of y is equal to the modulus of x squared minus 3. The other graph, the red line, is the line y equals 2x. So that's just a straight line through the origin, gradient 2. Now we can see on the graph we've got the intersections at these points. However, of course, we want to find the x values algebraically, so we can't rely on the graph to give us a exact value necessarily. So let's look at how we can use the algebra to find these critical points where the graphs cross. So we want to find when is the modulus of x squared minus 3 equal to 2x. Well, for portions of the graph which have come from the original function x squared minus 3, in other words, where x squared minus 3 is greater than or equal to 0, we can say that the intersection must be when x squared minus 3 is equal to 2x. That means that x squared minus 2x minus 3 is equal to 0, which gives us a quadratic that factorizes as x minus 3 and x plus 1 equal to 0. So that gives us a value of x is equal to 3 or negative 1. But we have got the condition that x squared minus 3 is greater than or equal to 0, and therefore we can discount that negative value to say that x is equal to 3. So this first point here is at x is equal to 3. If we're using a portion of the graph which has been reflected, as for the second point there, then we know that x squared minus 3 is less than 0, and therefore we need to take negative of the function, so minus of x squared minus 3, and that will be equal to 2x. So this time our quadratic is x squared plus 2x minus 3 equal to 0, and that factorizes with factors x plus 3 and x minus 1. And therefore x would be equal to negative 3 or 1. But again, we want x squared minus 3 this time to be less than 0, so we can discount the value of negative 3, meaning that x is equal to 1. So this second point here is at x is equal to 1. Now that we know the values for the critical values, then we can consider the inequality. We want to know when is the modulus of x squared minus 3 greater than 2x, or in other words, when is the green line above the red one. Well, we can see therefore that we have to be below the value of x equal to 1 or above the value of x equal to 3. So the solution to our inequality is that x is less than 1 or x is greater than 3. So here it is, the solution typed out. So what we did, remember then, was we sketched the inequality and the line. It is really only a sketch that's required, it doesn't need to be accurate. So that we could then have a picture of what we're trying to do, we needed to locate these critical values. The first point came from where x squared minus 3 was greater than or equal to 0. In other words, it was from a portion of the graph that hadn't been reflected, and therefore we could simply use the function equal to 2x. The second point comes from a portion of the graph which has been reflected from the function x squared minus 3. So it was below the x-axis, therefore we needed to use negative of the function. Once we've got the two critical values, x equal to 3 and x equal to 1, then we can use the graph to help decide what are the regions for which the inequality holds. Well, that's the end of this particular video, and there will be one now looking at graphs of y equals 1 over f of x.